Question 3 is essentially a rates of reaction question with a few other little bits in it. First of all, balancing the equation. It's probably easiest if you just look at the oxygens, really. The hydrogens seem to be balanced already. To get the oxygens balanced, you've got to have 2 there and a 2 there. The other way to think about it is to think that each hydrogen peroxide molecule turns into water by losing one of the oxygens. Okay, you create 2 oxygens on this side, so therefore you must have lost 2 hydrogen peroxide molecules to begin with, which means you must make 2 water molecules. For part B, the variables, okay, whenever you ask about variables, a variable has to be something that will influence the dependent variable, i.e. something that's going to change the reaction. So if it's a question about rates of reaction, you need to think about what variables affect the rate of reaction. In this case, you've got hydrogen peroxide, you've got a catalyst, but you should also be thinking generally, what do I know affects the rate of reaction? The most obvious thing to write down would have been temperature, okay? And then you could also have had things to do with the catalyst, like the surface area of the catalyst. You could have then also had mass of the catalyst. You could have had the number of moles of the catalyst. And similarly, we'd have allowed the volume of the hydrogen peroxide solution. Okay, you can't really change the concentration of the hydrogen peroxide solution because that's the whole point of the investigation. That's what the independent variable in the test is. Then here's the results. What they've done is just take different volumes of hydrogen peroxide solution here and diluted them with water so that the total volume in each case is the same. Then they've timed how long it takes to collect 20 centimetres cubed of oxygen. Okay? And the question says, well, why doesn't this carry on going down to 0 and 10 of water? And the point there is that water, if you just use water on its own and no hydrogen peroxide, then there'll be no oxygen produced, so you won't get anything. Calculate the mean rate of production for 6 centimetres cubed of hydrogen peroxide. So the mean rate of production, you have to look at the unit here, centimetres cubed per second, okay? So that means, if it's per second, that means that the rate is equal to the number of centimetres cubed produced divided by the number of seconds, okay? In every single test, the whole point is you're collecting 20 centimetres cubed of gas. Then you think, well, how long did that result take? 26 seconds. So the number of seconds is 26, and therefore that answer comes out as being 0.77. Okay, carrying on to the graph, you have to think about, well, what's this axis on the graph? This should be the dependent variable, so you change the volume of hydrogen peroxide across the x-axis. What have you measured? You've measured exactly the thing that's on the right-hand side of the table, i.e. the time to collect 20 centimetres cubed of oxygen. So this is some sort of time. You might have written out the whole thing, which is fine, measured in seconds. Then if you went back and read this bit here, okay, the student did not close the tap on the funnel after adding the solution. What's this result for 4 going to be like? Okay, so you've got a value here. What time did it take when you had 4 centimetres cubed of hydrogen peroxide? Well, if you didn't close the tap, if you think about what would happen, just scrolling back to the diagram of the thing, if this tap here was left open during the, let's just get rid of all that, if this tap here was open during the reaction at the bottom, okay, you've got your hydrogen peroxide in there, the bubbles of gas are coming out, but the gas now can go through either of the tubes. So the gas, if this is open, it's just going to escape partly straight out there. Some of it will still go out here and push through the gas syringe, but you're going to lose gas out the hole through the tap, which means that it's going to take the gas syringe longer to fill up than it should do. So we'd expect our time taken to collect 20 centimetres cubed for that value to be too long. So the value for time will somehow be too high, so we needed to make a mark that was too high. In reality, it might actually take longer than the space is available on the y-axis, but anyway, as long as you put a point in somewhere above the line of best fit, you got the mark. Then this is a key bit of sort of exam technique. Show on the graph how you obtained your answer for the 5 and 5 result. So you had to look at the value on the x-axis for 5, draw a nice straight line going up, straighter than mine, and then coming across. And you ended up, if you read off the y-axis, you ended up with a value of 32 seconds. Then you had to think about what does a 10 volume solution at 10 centimetres cubed mean? Well, if the 10 volume means that it produces 10 times greater than the volume of solution used, if you have 10 centimetres cubed of hydrogen peroxide, that's going to produce 100, i.e. 10 times the volume of oxygen, okay, which is fine. But again, looking back at the diagram of the apparatus, the gas syringe you're using only has a capacity of 100 centimetres cubed. So if you try to use more than 100 centimetres cubed worth of oxygen, you're going to break the gas syringe or it's going to explode or something. So you basically just have to say that 100 centimetres cubed won't fit in the gas syringe.